Hi guys, welcome back to our channel. I'm Avni, and in our previous video we discussed number problems of logical reasoning. We talked about cubes, squares and prime numbers. We basically solved 3 problems, and one lesson that we need to take from that particular video is that whenever you've got number problems, there are a few patterns. For example, how you need to remember cubes and square roots and divisibility rules. These are the 3 conclusions we drew from our last video, and also we learned to solve the problems, right? In this video, we are going to be solving more of such problems and are going to be determining what are the other patterns that we also need to know, so that we can summarize it all, find all of these patterns and then practice them one by one. And well, let's just solve the questions and then figure out. Hi guys, welcome back to Avni's classroom. As discussed, we're going to be talking about more problems related to numbers. So we're just going to get started, right? The first question is the same, the odd one out. I'm not going to repeat the same sentence over and over again. I've written the options over here. So I'll anyway repeat the question. 4 of the following 5 are alike in a certain way and so form a group. Which is the one that does not belong to that group? The odd one out. So, okay. Now I'm feeling a lot more confident myself. Honestly, I have not solved these problems myself. So we are kind of on the same pathway. We are kind of on the same journey of exploring the patterns, right? So let's look at this problem. We discussed in our previous problems that there are a few square numbers and some numbers that click, right? So when I look at 120, let's say 120, I will use a different pen. Yeah, so let's say 121 is what comes into my head, right? Because if I talk about squares and cubes, this is what would come into my head, because it's 11 square. It is something that we know and we've seen and we've solved a lot of times. So let's connect it with that, right? 120 plus 1 equals to 121. So technically, this particular option is n square minus 1. We've done these problems, if you remember. N square plus 1 was the pattern that we followed, right? And then we found out one number that followed n square plus 2. But why then I'm discussing this problem? Because it gets a little tricky. Keep that in mind, that it gets a little tricky, and then solve it. Okay? I mean, obviously you're supposed to keep it blank, but right now while you're solving it, just keep it a little at the back of your head. Then you've got 290, right? You've got 289, which is 17 square. So this particular number is n square plus 1. In this particular number we did the same, and this also somewhere so see, when you look at it, it's n square plus 1, which means it's 289 plus 1. And you look at this, then this particular number would be n square minus 1. Why did I take this approach? Why did I confuse myself with n square plus 1, this and that? Because these additions and subtractions are something that we miss when we're solving the questions very fast. Okay, so now I'll speak in a very polite and subtle language and a very clear language. This was required so that you know, somewhere at the back of your head you keep processing this information. Now you see that square minus 1 is this option, square plus 1 is this option. We have established 2 different patterns. Let's check for 728. It's 729 minus 1, which means this is similar to this one, right? 728 plus 1. You can do it here. Like, you write down the options and you keep writing plus 1, minus 1 or something of that sort to establish that it's a square. So 728 plus 1 equals to 729. 120 plus 1 equals to 121. 290 minus 1 equals to 289, which is a square, right? And then you go here and you say plus 1 equals to 169, which is 13 square. And you go plus 1, which is equal to 19 ka square, which is equal to 381. And bingo, we found the right answer. I mean, this is the odd one out. But why is it tricky? It's tricky because of the plus and the minus, right? I mean, it seems very obvious when you say it, but when you are going on solving it over and over again, somewhere you're going to miss this. So I would recommend that even though we said that n plus 1 plus 2, those problems are still okay, right? Because there's a difference of 1, there's a difference of 2, and it's mostly in the different direction. When you're talking about two different directions, plus and minus, especially with one value, which also is 1, like it's a very small number, it gets a little tricky. So you will keep solving this problem in a different way. Because there are two approaches to this particular problem. We established 3 is the right answer, but let's somewhere stop that and solve it in a different manner. So how I solved it initially, not with this method, but this method you'll find in many books, but I solved it with this method. I'll write these numbers down here. I'll write it here, 168, right? 168. So what do you get from this number? What I could get was, I checked it for the divisibility rules. By 4. Because it was very obvious to me. And how do you check the divisibility by 4? You check the last two numbers, whether they are divisible by 4 or not. Here it's very clear that this particular number is divisible by 4. You don't even have to think twice. So if this is divisible by 4, then this whole number is divisible by 4. Same goes for 28. Again, you see the same thing. 9 4s are 28, so this is also divisible by 4. 90, although, is not divisible by 4. This is the odd one out that we picked out. Let's check for others. 80 is divisible by 4. 2 into 40, 80. 20 is divisible by 4, 5. Whatever. So all of these numbers were divisible by 4 because their last two digits were divisible by 4. This number, on the other hand, was not. So this is the odd one out. You can take both approaches. So this is logical reasoning. We can not always tell which is the right answer and which is the right approach. Mostly we can tell which is the right answer, but not always the right approach. So keep knocking out your brain every time you solve these problems. Keep looking at different perspectives. It gets very difficult to do that, but once you've achieved that excellence over the command over looking at one different question in 5 different ways, and even if you arrive at 5 different answers, doesn't matter, but if you have mastered that practice of looking at it in 5 different ways, it will only get easier and you'll ace it in your exam. Let's talk about more questions. Let's discuss more. We're probably covering 2 more in this particular video. This was question number 16, and I hope this number reminds you of the fact that how much have we covered till date, and that you need to keep practicing. I don't know why I'm repeating it over and over again, because I'm practicing how to tell you how to practice so that maybe you practice. I don't know. Just keep doing that. Let's get on our next question. So let's move on to our next problem. It is question number 17 of the logical reasoning section. One of the people in the classroom told me that I was going way too fast, and that I was speaking way too fast, and that they were missing it out somewhere in between. So I'm going to be a little slower, and I'm going to be talking a little more softly. Let's move on to the options. So this again is an odd one out question. Take 2 minutes or 3 or 4 or 5, whatever is convenient to you. Try to solve this question, pause the video, and definitely pause this video, because we're going to be following a lot of approaches, and then we're going to be anyway concluding that this is not the right approach as always. So let's go. I hope you paused the video. Now that you've resumed, so we go to 26. Okay, so we've been solving all the questions related to squares, cubes, and also prime numbers. That's all we have done. So when you look at this number, what is the closest square root that you can see? Square number that you can see? It is 25. Then you go to this and you see it's 36. If you try to establish patterns between the two, you see it's 25 plus 1. I need to use a different marker. It's 36 minus 2. You go look at this one, and so basically not every problem will give you a solution for square roots or prime numbers. This is a very tricky problem. I won't try to approach it in many different ways, because I know the answer to this question, so I'll just come down to that. Although when you are looking at these problems, uh, don't just try to uncover one layer. So in our previous questions we were uncovering only one layer, that this was minus this, minus or plus or whatever it is. Here we are not focusing on patterns. This question has got two layers, in which we are going to be focusing on the pattern and then what answer we get from the pattern. That's the second layer. So let me try and explain it in a better manner. We have 26, 34. All of these are even numbers, aren't they? So if they are even numbers, they will definitely be divisible by 2. That's the basic understanding, and we all know that. We don't need any divisibility rule to tell us that, although that is the divisibility rule, but okay. 26, you divide it by 2, you get 30. 34, divide by 2, you get 70. 72, divide by 2, what do you get? 36. 46, divide by 2, you get 23. 38 divided by 2, and you get 90. And now look. So technically this is a prime number, 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 this is not the prime number, and that is the odd one out. This is what I meant by uncovering the layers, by not just noticing the patterns but also focusing on the results of those patterns. Everyone was divisible by 2, but that was not a solution. So when you do this, no, so everything is divisible by 2, that's it. You stop there. That must not be the pattern. No. You go and look at the answer as well. That's the second layer. And as you keep solving these questions, you'll become more familiar with this. With this, we'll move on to our next question directly, because this one was one of the unique ways of approaching. This might have made you realize that it's not only important to know the tables, the squares, and not just addition and subtraction, but also there are a lot more things. So maybe this solution could be, maybe the options were different and the solutions could be that each one of these solutions is divisible by a prime number that we did, and the answer is also a prime number. No, it can't be that. So for our last problem for this episode, for logical reasoning for numbers, we have this. And this time I don't want you to pause the video. I want you to look at it with me. We're going to be moving from the first to the last step with each other. So in the beginning, as we discussed, the first approach to solving these kinds of problems was to look for squares. Okay, let's look at these numbers. So 98, nearest square would be 100. Then you look at 133, nearest square is 144, which is way too far. Then there's 91, nearest square is 81, way too far. So when you look at these things, you are somewhere able to establish the fact that it can't be squares. It can't be related to squares. Why? Because all are so random. You look at 3 numbers and you'll realize it. So there is no pattern that you can establish. So let's discard that. Now we also took a prime numbers approach. So 98 is not a prime number. This is not. This is not. This is not. This is. It's very clear. Very, very, very clear. These are not prime numbers. So it's got nothing to do with prime numbers or non-prime numbers. If you want, you can test it out, right? Divide by 2, divide by 3, divide by 4. This is divisible by this, that. You keep on doing it. But when you look at these numbers, I'll grab this. One common thing that you will notice is, when I look at 91, I can easily say that this particular number is somewhere like, let's say, what came into my mind was that this is divisible by 7. When I divide by 91, I know the answer is 13. Why? Because as a kid I've been repeating this. 13 7s are 91. So it somewhere clicks. Okay. Now I look at 104. And I somewhere see that, no, I mean this number is divisible by 13, by the way. It would click you if once you start solving more and more problems. This number is divisible by 13. Now, when I look at it, it's divisible by 13 and I establish here that this one is divisible by 7. It becomes a sole responsibility of a person who's solving this problem that you test it for 7. Interestingly, this is divisible by 13, yeah, whatever, but let's test it for 7. To test it for 7, we'll come back to this number, But before we come back to this number, let's move on to this. We solved this particular number in problem for this particular number in one of the questions, if you remember, 133, and we established that this is divisible by 7. So this is how we did this process of 140, which is obviously divisible by 7. 7 into 20 equals to 140, and then we subtracted 7 and then we got 133. If you remember, this was our approach. This is not random. We are all doing random things. There is no pattern involved in this because we don't have any rules or patterns in our head. So it's just going on random. Great. 112. Is it divisible by 7? Of course it is. How? 16 sevens are 112. We have been taught that. So this is why I also mentioned how important is it to remember tables. At least tables from 1 to 20 you should be having learned by heart. I mean, they should be in your brain the moment anyone says you. 16 sevens are 112. It should be there. Like 16 eights are 128. Right in the front. Then you've got 98. How do you test for this? Whether it's divisible by 7, it's 90. So randomly, either you remember the table of 14 or you just randomly see that 7 into 10 equals to 70 and plus 28. And 28 is also divisible by 7. So this number is also divisible by 7. So these are all random stuff, right? This is all random stuff. All these 4 numbers we established are divisible by 7. We test for 104 now. So let's say we test it like this only. So 98 is divisible by 7. 104 is 98 plus 6. It should have been 7. So this number is not divisible by 7. Random. But this randomness is also going to eat a lot of your time. So we'll go back to that process where we thought that this was divisible by 7 and we thought that this was divisible by 13. Now we'll bring in the divisibility rule for 7. What is the divisibility rule for 7? I'll take a random number right now. I want 343. Okay, so here what is the divisibility rule of 7? I'll tell you. The last digit you multiply by 2 and you subtract it from this number and you check whether the product is divisible by 7 or not. Simple. You just have to learn it. I will talk about how we have this particular rule in place. There are some roots and some mathematical rules that give birth to this whole divisibility rule, but let's just keep this in mind for now. So what you do is, you've got 34 minus 3 into 2, which is 6, which equals to 28. Is 28 divisible by 7? Yes, it is. And so this gets interesting, you know, like let's say you have a bigger number. Let's say you've got 4, 2, 1, 2 and you want to test for this. So you do the same, right? You multiply it by 2 and then you subtract it and then you keep doing it. But there are other divisibility rules also. Mostly we'll be concerned with these digit numbers only. Like obviously all that's important in logical reasoning is finding patterns. So we'll have a look at 2 more examples for solving this particular problem with this divisibility rule. Okay? So 98. Is it divisible by 7? Yes, it is. How do you check it? 8 into 2 is 16. Correct? So 9 minus 16. What do you get? Minus 7. Is minus 7 divisible? Yes, it is. So the same thing we'll do for 112 also, just so that you get very well versed with this rule. 112, this 2 into 2, which is 4. 11 minus 4, which is 7, and 7 is definitely divisible by 7. So here we found out which was the odd one out. It was 104. How did I come to know that it is divisible by 7? Because I was familiar with the numbers. So this is one more important reason that you need to practice a lot. But now we have established a few patterns in this course. So I'll write those patterns down here. First, square. Second, cubes. Third, prime and non-prime numbers. Prime numbers. Fourth, divisibility rules. And fifth is tables. what I would expect from you after watching this video would be to learn all the tables that you can, at least till the till 20. I mean, I know of course you've learned it in school, but practice practice them over and over again, so that the moment I ask you what is what is 19 into, let's say, 7, you're able to click 133. It's just there on your tongue. So practice these. And then about squares, we'll discuss this in our coming videos, but I would still expect you to at least learn the squares till 20, right? We'll discuss different hacks as to how you can learn it easily, but for now just do it. And then there's cubes. Learn it at least till 10. We'll keep talking about different methods, different ways, different tricks to remember all of those. And then there's prime numbers and divisibility. The rules that I talked to you about in these videos, I expect you to remember at least them, like how to tell if a number is prime or not, and divisibility rules for 4 and 7 that we discussed. I will expect you to remember them, so that in our next videos, whatever we talk about, you're able to gather in a much faster manner. Okay, so thanks for watching. That's it for today. So those were another 3 questions that we solved for numbers in logical reasoning. I hope you enjoyed this episode, and I hope you got a better insight into solving these questions, because yeah, we discussed about prime numbers, we discussed about divisibility, but now we know that different combinations, different variations of it are also being covered here. So it's not just important to remember the patterns, but also keep experimenting with it. Just like how we found out that how important it is that we remember the tables. Of course, we all know the tables, but how does it click that you need to divide it by this particular number and then test? So it will eventually come with practice. I hope you guys are practicing a lot. We anyway have a lot of PDF links in the description below, from which you can download a lot of papers, questions, and solve them. If you've got any queries regarding any questions, or you want any other topics to be covered by us, any particular question to be solved, please feel free and comment, and we'll get back to you definitely. Thank you for watching, and keep practicing.